Hello everyone, welcome to Integrated Math 1. We're talking about 9.7, summarizing categorical data. Make sure you put your first and last name up here. Don't just write first and last. And don't forget to put your period number. Once again, we are discussing summarizing categorical data. So the first thing we have right here is our vocabulary. A two-way frequency table is a contingency table that collects data for two different categories. And it's collected from a group of people. Okay, well, what's an example of this? Well, let me show you. So a two-way table, if you look at this example I just pasted in here, we have gender, male and female, and then maybe like what sport do they play or what is their favorite sport. And then you can say, all right, which number of males like baseball? And then or what is their favorite? Or which ones play this sport? And we're like, all right, males in baseball would be 13. So joint frequencies are values for every combination of subcategory. Category. So, for example, is a joint frequency of the number of females who play basketball. Okay, well, that would be 16 right there. Marginal frequencies are the totals of each subcategory. So this would be like the total column or the row. Columns or rows. So blank is the marginal frequency that represents the total number of males. Well, 48. That is the marginal frequency. Let's go on. So we have to be able to create a two-way frequency table. So at the moment, I'm going to tell you, sometimes it can be hard, sometimes it can be easy, but what you're going to do is you're going to have to use some logic to figure out how can we fill up every single square. We have to fill up every square. How do we do it? Well, we have to think logically and go from there. So let's do that. A store manager kept track of the size and material of the 200 bird baths sold. So that's going to be the total number of bird baths, like 200. That's the total number in 1 month. Of these bird baths, 40% were large bird baths. Okay, well, 40% of 200 would be 80. 40. Now we could do it two ways. We could say, all right, 200 times 0.4 and get 80. Or we could be like, all right, it's 40 over 100 is equal to 200 over what? And we're like, oh, it's 80. So I know that the large bird baths is 80. Well, then how much is the small? Well, these have to add up. So this plus this has to equal that. Well, then it's going to be 120 because 200 minus 80 is 120. Now it says, hey, 54% were ceramic. So I can either go 54%, figure out what is 54% of 200, which would be 108. So I could either times 200 by 0.54 and get the answer, or I can just figure it out using proportions. It says 8% were small wooden bird baths. So that's going to be 16. Well, small and wooden would be 16 right here. Now, the only way we could figure this out is to figure out have one empty right here. But looking at this, I have 2 left. I have 2 left. I have 2 left. Can't figure it out, so keep going. The store sold 24 plastic bird baths. Okay, 24 large plastic bird baths right there. The store sold 40 more plastic bird baths than wooden. So I know that I could say, all right, so wooden plus plastic, that'd be 200 minus 108. So 92 is equal to wooden plus plastic. All right, what's up next? Yeah, I know that 40 plus W is equal to P. 40 plus W. Yep, that's it. 40 plus W. So now I can just, switch it out. I know that if I add W plus P, but I do the substitution right here, I have 2W plus 40 is equal to 92. All right, well, Using solving an equation, I could figure out that 2w is equal to 52, divide by 2, and I get 26. Well, if that's equal to 26, then 26 plus 40 is 66. Well, now I know that if this is 24 and that's 66, I could subtract it out and I get 42. Well, now I have all this, but I have one left. So 16 plus 42 is going to be 58. And how much more to get to 120? Well, 62. All right, well, now I can fill in these. 62 plus what equals 108? Well, that'd be 46. Now I can either go this way or I can go this way. It doesn't really matter. The answer is going to be 10 for large wooden. And so the problem with this one is you're going to have to do some mental gymnastics sometimes and figure out, all right, how can I figure out these boxes? The one trick is, hey, if there's only one left, it's a simple addition or subtraction problem. Sometimes there's a relation that we have to figure out, and we do it through equations. All right, let's go on. So a relative frequency is the ratio of the number of observations in a category to the total number of observations. So basically what we're going to do is we're going to divide by the total, divide by the total, divide by the total in each of these little boxes right there. So to a relative frequency table, divide each value by the total number of observations and replace them with either, decimals, so let's write that in, decimals or percents. It doesn't matter which one, whichever one you prefer, do it. So let's do example 2. Use a two-way relative frequency table. So basically, what we have to do is we have to divide each of these by 1099, but 1060. So I'm going to just quickly stop this, and I'm going to actually just have to do it for you right now. So go ahead and just wait in 3, 2, 1. All right, so here's our percentages. So if we divide by the total number, and then we'll get a decimal, we just have to times it by 100, and then we get our percent. So if we divide 299 by 1060, we really got 0.282 around, and then we times it by 100, and we'll get this 28.2. So what's happening here is it's not going to be exactly. It's going to be around. We're rounding here, okay? So just be aware of that. Make sure you round up. If it's 21.5, you're going to round up. If it was under 5, it's going to round down. Actually, make sure you go to the 10th of a percent. All right. Let's go and answer the question. Do more parents check what sites their teens have visited, or do more parents not check? Well, I mean, you could literally just look at it, and the numbers will tell you. But then we could describe hey, look, it's this percent compared to this percent. It's this percent more. So looking at it, it looks like, all right, if I add 22, it's 22% more. So we could make the comparison and say, hey, it's 22% more, as opposed to just saying, hey, it's this number more. And that's a little bit easier to be able to, summarize the data and, make it relatable. All right, go ahead and write your sentence frame. And here we go in 3, 2, 1. All right, so example 3. Use a two-way conditional relative frequency table. So according to the U.S. Census Bureau, voter turnout describes how many eligible voters show up to vote in an election. The table shows the number of eligible voters who did and did not vote in 2012. for the oldest and youngest eligible age groups. Organize the data in a conditional relative frequency table by age group and interpret the data. Okay, so hold up right here. Let's bring it on down. And so here we go in 3, 2, 1. So we think first, all right, they want us to do it by age group. So we're going to, instead of doing it by the total, we're going to do it by age groups. So we're going to divide each of these by the total. So I'm going to divide this one by 25,790. I'm going to divide this one by 25,790. I'm going to divide the bottom one by, now there was a little error in the like it should have been more clear, but this was 16,724. So I'm going to divide this by 16,724. So I'm going to do the math on my calculator, and then I'm going to write it in 3, 2, 1. All right, so here's our data. So now we can make a couple comparisons. Compare the number of people who voted in each age group. Okay, well, looking at this, it's like, hey, look, there's more 18, like I would say, hey, look, there's more 18 to 24-year-olds. Like if we did the math, it looks like about 1,200 more people voted for 18 to 24-year-olds. But if we look at the percentages of their total group, hey, 75 and older are definitely voting more than 18 to 24-year-olds. And this is where we get into this idea of voter apathy. It's like, hey, these guys aren't voting. And if these guys aren't voting, are politicians going to spend time trying to convince them to vote? Or are they going to convince the people who are already voting to vote for them? That's kind of like half the battle sometimes. All right, so for your credit, I want you to compare the numbers. Basically, hey, which ones are bigger and what do you think that means? And then compare the percentages. Which ones are bigger and what do you think that means? I already said it out loud in the video, so go ahead and take this and go for a run with this. All right, guys, that's it. I hope you guys have a wonderful day. I'll see you guys in class. Bye.